Hey everyone. I thought I'd have a quick look at running through how to do Azure IoT hubs and device provisioning. One of the things that's included in this particular MS Learn set of modules is using X509 certificates, which I'm not massively au fait with, if I'm honest. It's not something I get involved with all too often, but it's just something I need to fill in a little bit of hole in my knowledge here. So I thought it'd be a good excuse to go through and stream this particular module. I never know when I'm starting these streams whether I've started or not. So I Twitch open there to see whether or not I was streaming, and that's probably what you heard at the start there. So and me closing it immediately when I realised that I could hear myself speaking. Either way, I do live in a house with a family, so no doubt there will be noise in the background, so apologies if you hear that, but kind of get used to it. Either way, if I zoom in a little bit on this so that you can see it a little bit better, it goes on to explain here that we're going to be creating an IoT hub and a DPS, device provisioning service instance, and we're going to be then linking the IoT hub to the DPS, and then using X509 certificates and some demo C code, I think, to be able to then provision a simulated device to the IoT hub through the DPS. I've done a little bit of DPS stuff, so that's fine, but I've not done much in the way of certificates, and I've not tried this particular simulated C code either, so it'd be interesting to try that. I have run through one of the modules quickly in the past, it seems, because there's a little tick next to it, but other than that, I've not done all that much, so I'm going to get on now and have a go with it, see what happens. So this first module will just be an introduction, so we can click on that. We don't need to know very much according to those prerequisites, just some basic knowledge is fine. I think it's C# code rather than C code, so that's good. This module builds on the remotely monitor and control devices, so that's just a basic introduction to IoT and IoT hubs. So we're going to create an IoT hub, a custom Azure IoT hub. I'm not quite sure why it's calling it a custom Azure IoT hub. Then we're going to learn about device provisioning. There's some notifications coming through my system here for some reason. Yeah. And then we'll learn about certificates, which is good, kind of the reason why I'm doing this. And then we'll create a DPS and a group enrollment. So there's an individual enrollment, but you can set up keys for one device to connect through DPS and then provision itself to the IoT hub. Or a far more likely solution is that you're going to be doing a group enrollment for a whole heap of devices that are going to dial in and provision themselves. And then we're going to create an X509 certificate and some Leaf certificates, and using some downloaded scripts to do that. And then we're going to be using an app to send device telemetry to the IoT hub using Visual Studio or VS Code. I'll probably use VS Code if I can. And then we're going to test multiple IoT devices connected to the DPS. So that should be good. Again, that's a reminder of those prerequisites. And a basic idea of the scenario here. So this is a cheese cave where I guess they're likely to have multiple cheese caves with sensors in them, and they want a way of these sensors to be able to then dial in and provision themselves to an IoT hub, which is good. So they want to process telemetry from all 30 of these sensors. Oh, that doesn't look... I mean, I'm not a big cheese fan, so apologies if people are tuning out because I don't like cheese all that much, but yeah, that doesn't look... It just looks... Yeah, no, that's not right. So the first thing we're going to do is we can actually do this in a sandbox, but I'm not going to do that because the number of times I've done that and then the sandbox is timed out before I've had time to finish. But this will spin you up an environment that won't charge you anything to use, so that's quite a handy resource actually. But I'm going to do that directly in my IoT hub. I'm an MVP, so I get some credits to use, so I'm going to use those. So I need to go ahead and create an IoT hub. I knew that would be coming, so I've begun that process earlier. So you can just search for IoT hubs in here, and you can create a whole new one. So I'm going to create a new resource group for this. I'm going to call it MS Learn DPS, And then I'm going to use North Europe for this because that gets a lot of the cool services first, and it's quite close to where I am. And so I'm going to call this MS Learn IoT Hub. I'm going to call it MS Learn DPS IoT Hub. Let's do it that way around. We don't need to worry too much about this. We can leave that for now. Size and scale, I'm going to leave this as standard. I've already used my free one, and you can only have one per subscription, so I'll leave that as it is. Yep, that all looks good to me. Don't need to add any tags, so let's create that. If you flick back to this, I'm just going to make sure there's nothing I've missed in there, but that all looks pretty standard. So this module is just an overview of DPS and X509 certificates and enrolments. So it uses X509 to validate the devices. So this is their way of the attestation method that the devices are going to use to be able to connect into DPS and then onwards to the IoT Hub. X509 uses public-private key encryption. One key is public, one key is private, and you can hear my children in the background. Use of the keys for the encryption distorts the text. I'm not going to sit here and read through all of this, but I'm going to just quickly digest it and try and paraphrase a lot of it. So private keys used to encrypt the message, and the public keys used to decrypt it, and they form asymmetric encryption. Public key cannot be used to derive the private key. The underlying math is one-way functions. So to keep keys private, a public key PKI is needed to prevent the keys from being lost or stolen, and this is a potential disadvantage. So PKI is built into the DPS, so that's good. And users of the service don't even need to know their own private keys. Private keys are generated by helper tools, publicly available and stored in the X509. So the user doesn't need to do much more than upload them to the DPS, and a password protects that private key. So to validate the authenticity, certificates are signed, and you can either do that with a CA or by supplying self-signed. Generally, you'd use CA in production and self-signed for prototyping work like we're doing, so that's perfectly fine. There's no cost for self-signed either. If you use a CA, then you're going to have to pay for that. That's kind of what an X509 certificate looks like in text form. So with X509 certificates and the PKI, there's no need to distribute the public keys when creating key pairs. And another advantage is that you can maintain a list of invalidated certificates. So that's good to know. So a third way of signing certificates. A certificate can be used to validate another certificate. Yeah, so you start off with a root certificate, and then you can leaf off other certificates that are authenticated to that one. So the subordinate certificates can be intermediate certificates. An intermediate certificate is, again, not used to validate other certificates. A root certificate can be used to validate a number of intermediate or leaf certificates. So in this sample, we're going to generate a root certificate for all our devices. From that root, we're going to generate one leaf certificate for each device. So that's good. All these certificates are going to be self-signed. A DPS service can be linked to one or more IoT hubs and can be thought of as a system for managing your certificates and your enrolments. And we'll see later there's different ways of enrolling devices. Depending on how you want to do it, like lowest latency or just balancing them, things like that. So yeah, this is what this is saying here. So individual and group enrollments as well. So this is how you enroll the devices, not where they get enrolled. So in our scenario, the group enrollment provides the solution we're looking for. One group works with one certificate, a root certificate, and a number of leaf certificates signed by this root. So I mean, this is the stuff I need to learn because I'm aware of all of this and I kind of understand how it works, but I've not been that involved in using it. So this is good to learn this. And enrollment maintains information on all devices that have tried to register. That's fine. Individual enrolments are best used for devices that you have a unique configuration and require greater security. Does that make sense? Unique configurations aren't what we're looking for in this scenario. An allocation policy, that's what I was mentioning earlier. We're not going to delve into that policy, but we will see it in a bit. But allocation policies can only apply when you've got multiple IoT hubs. We're only going to have one anyway, so we're not going to be able to do that. After creating enrolment and a self-signed root certificate, there's one more process necessary, a proof of possession. When uploading certificates to Azure DPS, you'll be asked to generate a verification code. Proof of possession of a certificate is provided to DPS by uploading a verification certificate generated from the root certificate with this verification code. Jeez, okay. The verification certificate is chained to the root certificate. This process is how you provide proof that you own the root certificate, and there's no need to provide proof of possession to leaf certificates, because we've already proved that we're fine. Sensitive data such as certificates could be stored in a HSM. Yep, HSMs are physical devices, either in the form of an external drive, an internal plug-in card, and HSMs are designed to protect digital keys, and they're kind of your little ownership space, and they can be invalidated to clear everything out. An alternative is Azure Key Vault as a resource as well. But the resource ensures that apps got no direct access to secret data. So, okay, well, that kind of makes some sense. I'm sure I'll forget that immediately, but even so. So it's still telling me about the sandbox. I'm not going to use it. So now we need to create an IoT Hub device provisioning service. Oh, look, I didn't click create on that. But that's okay. So that'll go ahead and start creating. And device, actually, if you type IoT Hub device provisioning service, then that'll appear in the marketplace. I'm going to call this MS Learn DPS, and that'll do. Resource group, we're going to put that into our MS Learn DPS, and in North Europe, create. Is that doing it? I don't know. Yeah. Go to resource. There we are. So I'm just going to pin that to my dashboard. Pin it. And my IoT Hub is still deploying. Oh no, this is it. So I don't know what that's doing. MS Learn DPS IoT Hub. Good. Go back to my dashboard. So that's still provisioning, which is why it isn't appearing in there. If I'd have clicked create, then I wouldn't have been doing this waiting. I was too busy reading. Come on, IoT Hub. I'm not sure what it's doing. It's been a bit slow today. I guess I'm doing this in the afternoon, evening, so most of America's online now, so I guess that's going to slow us down a little bit. I think that's done now. Let's pin that. Yeah. So we should be able to go back to our dashboard and refresh it. Doesn't like that very much. Oh, there we are. There, our DPS and our IoT Hub. So we've created that. We've been through that. And now we need to link the DPS resource to our IoT Hub. I always kind of imagine it the other way around, really, where we're linking an IoT Hub to the DPS, but semantics in that point. But we can do that from the DPS and in linked IoT Hubs over here, and we can click Add. And then it'll automatically select the right subscription. I can choose our IoT Hub, MS Learn DPS IoT Hub, and an access policy. Now, I wonder, has it actually asked me to create a new access policy? No, it's happy with IoT Hub owner. I always like to create a new access policy now. I guess it's not trying to confuse us too much, but I like to be able to revoke access policies if I like. So, but I guess for the purposes of this, it's fine. And we can link those two things together. And while it's doing that, we can flick back and see what else we need to do. Here's the allocation policy it was talking about earlier, look. So it said we weren't going to dive into it all that much, but it's just going to use this evenly weighted distribution, so like a load balancing type effect, but really won't make any difference as we've only got one. If we had more than one and you had an IoT hub that's got one device, then it would try and put it into the next IoT hub, so that also had one, and then the next one if you've got three. Lowest latency, if you've got them in different regions, it will try and put that device into an IoT hub closest to itself. So that's how that works. And then you can have a static configuration where you can have a list and do it like that. I think there's actually a custom configuration as well where you could do it with an Azure function, but it doesn't appear to be on that screenshot. I wonder, is it on here? So that's added. It will have done. My MS Learn DPS IoT Hub. Manager allocation okay, so no, it's not there. I don't know how we did that. I can't remember. Anyway, evenly weighted is what it wanted us to use, so that's perfectly fine. So we need the ID scope, which is here. And this is kind of the main thing we're going to be using to be able to provision devices. Right. The first time we create an EX509, we need to download some tools. So right-click on the Azure Cloud Shell and click Open Link in New Window. I don't really want a new window. I want a new tab, thanks. What? Why was he saying that? I wonder. Oh, okay. Yeah. It meant in that dot. So sign in. I mean, I could just be doing it underneath here, but I guess if I'm zoomed in, then this might be slightly easier. Can I make the font size bigger? Yes, I can. Hopefully that's big enough. I can't do any more zooming than that. Oh, I can. There we go. Yeah, it wasn't letting me before. Ooh, might be a bit too much now. I think that'll be enough. Ensure the bash shell option is selected. Bash. Confirm. So that's me in there now. Run the following script. It creates a certificate directory in shell storage and downloads some helper scripts to it. Can I just... I don't think I can copy that whole thing. Might be able to. Maybe. Let's see what that does. These helper scripts are downloaded from the Azure IoT SDK C open source project, hosted on GitHub. Project's part of the IoT SDK. Cert Gen helper script will help us demonstrate the purpose of CA certificates without diving into the specifics of OpenSSL. There's some more instructions on that if we want. Don't use these helper scripts in production. Fair enough. Run the following command. We're only interested in a root certificate, so let's try running that. That worked. We need to download the root certificate to our local machine, so let's download that. Some of this seems familiar because I think we did some of this with digital twins as well, or something. a little download. There we go. Create a new folder in your documents folder called Cheese Cave Certs. Or something familiar, and copy the certificate file you downloaded into the Cheese Cave Certs folder. Okay. I'm actually going to do that on my root. You can't see this, it's off to the side of the screen. Right, I've copied that across. In the Azure portal, navigate to the Cheese Cave DPS resource created earlier. In settings, click certificates. Certificates. Click add for the certificate name and enter an understandable name. Cheese Cave DPS root. Just call mine that. And we need to open a file. Uploaded, so that's good. I'm assuming click save. Right, it's saying unverified, so this is what it was talking about earlier, where we need to verify that that's us, I guess. Yep. Before the CA certificate can be used to authenticate, we need to establish proof of possession. In the certificates pane, click on the certificate to open the certificate details pane. There it is. If you're wondering why this is blurred out, I'm using a tool called AZ Mask, which is quite handy for this. It doesn't blur everything out, sadly. I wish it did, but it does blur out a fair amount of stuff. It's quite handy. Click on the Generate Verification Code. Copy the verification code that is displayed above the Generate the Verification Code certificate. Oh, that. Copied. There's a button to the right of the text box. Copy the code. Okay, yeah, just done that. Open a text editor such as Notepad and paste in the verification code. I'll do that in VS Code. That's that. Proof of possession of the CA certificate is provided to DPS by uploading a verification certificate generated from the root certificate. The verification certificate contains the verification code you just generated. Leave certificate details pane open while you generate the verification certificate. If you close the pane, you'll invalidate the verification certificate. That's good to know. And you'll need to generate a whole new one. Copy the following command to the text file containing your verification code and contain, yeah, okay, so this. I need to do that over here. Paste that. And then we're going to need this again. And paste that. And then I'm betting it gets us to download it. Yep. And that'll pop up, allow that to download. And over in the side here, I'm just going to grab that certificate. Select the file, so over here you can do this. Verification code, verify, and hopefully this changes to verified. Hey, that's cool. So I'd never done that before or seen that been done, so that's something new for me. So we've created a root certificate and validated it to Azure DPS. The next step is to create a group enrollment and link it to the root certificate. So over here, we need to go to Manage Enrollments, and then we'll have two different ways here. You can either create this enrollment group or an individual enrollment. So we've got nothing in here at all at the moment because we've not done anything. So I'm going to add an enrollment group, no doubt. And I'm going to call this MS Learn DPS Devices. Make sure we've got certificate on, so that's what we're going to be using. I'm guessing we may be using intermediates. Let's have a look. No, CA certificate. And these settings are the defaults, that's fine. In the primary certificate drop-down, select your CA certificate. Only got one, so that's that one. And the secondary certificate, leave it to set to no certificate required, and you're not required to have a secondary certificate. Leave, select how many you want to assign devices to hubs. It's evenly weighted. Indeed. And we've only got the one hub, so that's fine. We could link a new one at this point as well. Leave reprovisioning settings as default. Yeah, that kind of makes sense. If you're going to move them between hubs, you might want to reset their configs or migrate it. Depends on your particular use case. So that looks good. And it annoys me that the save moves depending on where you are in Azure. Nearly swore then. Right, next. Oh, an exercise again. So now we're going to create multiple leaf certificates. In this, we need to create one leaf certificate for each device that we want to send telemetry to the hub, so that makes sense. 2's company and 3's crowd. So let's go for a crowd of devices. Remember, in our scenario, we've got 30 cheese caves and 30 sensors. So we need to run another command. I'm going to call mine something different. I've already veered off. MS Learn DPS Device 1. And we're going to be verifying the leaf certificate was created. You should see numerous console messages, blah, blah, blah. And we do. I mean, that looks fine. Download it, then we can do this. Is that right, look? I don't think that's right, personally. New device .cert.pfx. I would have thought it would be this, but let's have a look what's in there, shall we? So certs. No, it is new device.cert. That's interesting. I mean, why has it called it that, I wonder? Surely you'd call it MS Learn DPS Device 1.cert.pem. So it must be the script we downloaded just chooses that, which isn't ideal. If you want to create multiple, you've got to remember to copy that every time rather than sort of copying them all in one go. Not ideal. So either way, we can download that then with this. I'm going to download. There we are. I'm going to go and grab that. So I have that then. Done that. So I've done that just there, and rename it to new device 1.pfx. Done. In the Cloud Shell, delete the new device cert files. Okay. Which is the point I was making. I wonder if it mentions that in a minute. So now I need to create device 2. And download it again, no doubt. I'm off copying files on this left hand side, there's no point showing that. So I need to change that to new device 2. I wonder, is it going to get me to do a third one? It is, so do that again. Device 3. Do another download. And I'm assuming that it's going to tell me to still delete. No, well, I'm going to delete it anyway because I might do this again and then I'll forget. And remember to go and get that certificate. Oops. Cert 3. There we go. Cert 3, just done that part. So now we've generated 3 leaf certificates. So what did we actually do there? Great device certificate. So that, yeah, it'd be interesting to see what the actual code is doing to make that happen. But I suppose we can leave that for another day. So in this unit we're going to create the code running on each sensor device. One of the goals is to make the code as identical as possible for each device. Yeah, that's sensible. The code will require one tweak as we prepare it, so that we can add the 1, 2, and 3 in there, no doubt. The code's going to be C#. Okay, good. I don't know where I got C from. Actually, I think that certificate generating stuff was all in C, wasn't it? Probably so. I think I've got .NET Core and C# installed, funnily enough. Open a terminal, Visual Studio Code, create a device called Cave Device 1, navigate to the Cave Device 1 folder, and enter the following command, .NET New Console. I can do this. Device 1. Now open this folder. Code. So I'm going to open all of that. I don't think we need that anymore. And device 1, so we can view a terminal. So .NET New Console. I'm going to zoom this in a bit so you can see what I'm doing. So we've got a new console app running in there. .NET Restore. Don't know why we needed to do that. Interesting. So I need to add some packages. Devices, Azure devices.client. Provisioning.client. Oh, whoops. And AMQP messaging protocol. You either have AMQP or MQTT. So this is telling us that we need to open this program.cs, which is just hello world. And we're going to replace some code in there. So add code to send telemetry. So we've got all of this lot. I'll paste it in here. Wow, there's quite a lot of code in there. I'm not sure I'm going to run through and look at what all of this is doing and explain it on this stream, because I'm guessing it's going to do some of that for us down here. But that's a fair amount of code. We need to change our DPS ID scope that we saved earlier, which was over here in the overview. Let's get that. DPS ID scope there. This endpoint is always the same. This is where these devices go to begin their authentication journey. We need a path to our certificate file name and our certificate password. I'm guessing I can either leave them in here, but I'm betting it's going to ask us to drop it into this same directory. Change your leaf path to the actual path to your leaf certificate. You can do this by replacing this line of code containing the string with the following statement. Yeah. I'm going to copy it into the directory. If it lets me do that. Tell you what, let's not do that. Let's just type it in directly in there, just in case it needs it to be specifically DPS. Is it like this? Yeah. I don't think that makes any difference, but I'm going to do it anyway. DPS. I'm actually going to rename my certs directory there. mslearn certs. And then we know that that's going to be, can I just drag this? No. Yeah, there is a way to be able to do that actually, but I'm not quite sure how. So new device.cert1.pfx. So C DPS mslearn certs new device. That looks about right to me. So we don't need to change the password then. Set the app running. This is, what's that complaining? It is. Also Avast's getting on with it. What's it complaining about? There's always something wrong somewhere when we do one of these. So what's he complaining about? Operation is not valid due to the current state of the object. Let me just try it again. All right, what does that mean then? I'm not sure this is going to help. Oh, what's this saying? This looks quite recent. Now I think I know what the problem is. If I do a .NET -- info, I had this before. We're actually using .NET version 5. Whoops. And really we should be using .NET version 3.1.402. And there was a way to, and I forget this every time, there's a way that I can actually .NET new specify version. So I can create a global JSON. Oh, I'm not in there. And I actually want to use 3.1.402. And now if I do a .NET -- info, then we should get there, reflecting any global.json 3.1.402. So what I'm going to do is just delete everything but that program.json. Actually, I'll take a copy of this whole thing and delete everything in there and do a .NET new again. Console would help. And then we can just run those commands to add the packages again. Devices.client. While that's doing that, let's paste all that back. Provisioning.client, and we'll need AMQP as well. There. Right. Assuming that that was the problem, then we can .NET run. I'm going to get over here, I've got Avast complaining. I can see over here that this is actually working now. But this is probably going to disappear and it's going to drop back into here. Because Avast is currently doing, you might be able to see that Avast cyber capture. Yes, that's disappeared. Now it's going to run it in here. So we can see that it's found a certificate there and it's using it. So our path worked and it's starting to send some telemetry up to the IoT Hub. Some simulated temperature and humidity stuff. There's a fly flying around as they do. So flicking back over to the I can get rid of that and that. We're going to create an app for the second device and then change that. So I mean, repeat all the steps above. We could do that. So it's not all that hard. We'll need a whole new device in here. Let's open this again. Actually, let's create a directory first. Well, I'm going to create, so we're going to need 3. So I'm just going to, oops, get ahead of myself there. Open this with code. Right, so it's going to open this again, isn't it? So let's do it this way. New window. I'm going to need another one of those as well, so another new window. See if it lets me do this. Alright, I'll do it this way. I'm going to open the individual device in device 2. Open with code. It's probably why it told us to do it in the first place that way, and just me ignoring them. open with code. But what I am going to do is copy that global JSON, paste that onto there and there. I suppose I could actually open a whole new terminal, couldn't I? And do it that way. And we can just flick between the terminals then. So, CE device 2. New. I'm just going to double check, just make sure that we've got the right version, 3.1.402, good. New console. Program. Oh. All of that again. Pop from, that needs to be cert 2. Which is fine. And then we need to, are we going to get access? Oh, we are, look. We can add these in as well. Oh, yeah, of course we are. Well, because we're in the same thing. I'm going to close those other instances of millions of them opening. Maybe it did open them and it was being slow. Oh well. So that's that one. Now I need to do the AMQP one. One. So that's good. I'm just going to double check I did that because I split off. Yeah, client, provisioning client, and AMQP. They're all there. I've changed that to cert 2. Copy that again. Oh, and then run that one as well, I guess. Should we check? Make sure, because I'm flying ahead. Creating the app, set the app running. Provisioning, device 2, that's that one running as well. Let's do another one. Device 3, .NET, -- info, not Fino. 3.1.402, and new console. That in, save it to the top, change this to a 3, and so this is all it needs to actually identify itself in this particular method, is just the particular certificate that you've already generated for it. You just copy that onto the device and it just uses that certificate and this, but of course it does mean that you have got to generate those leaf certificates for each of the devices you intend to use. So it's not kind of automatic from the device, but you would have created those, say, maybe in the factory that's building these devices. They will create a batch and then inject them into the devices, perhaps in a firmware programming step that they do. So that's the new console in there. And we need to add those same packages. AMQP. And then .NET run. I should get the same thing again. I might need to tell Avast to stop again like I just did a minute ago. Yep. Provisioning. There we are. And so they'll still all be running over there, so they're happy sending messages up to Iot Hub, which is cool. And we've just done the third device. I'm guessing by the fact we haven't got error messages that it has actually provisioned them correctly. But this particular module is going to be verifying that that has actually happened. So with the 3 console screens running, verify all 3 apps are sending telemetry. They are. In the Azure portal, for your IoT Hub, select IoT devices. So we need to go to the IoT Hub here. And then we can scroll down on the left and we have IoT devices. And we should have 3 IoT devices been provisioned in there. Our MS Learn devices 1, 2 and 3. I'm not quite sure why they're not appearing sort of 1, 2, 3. Or in fact, 1, 2, 3 in reverse order. Might be a reason for that, might not. Not sure. Authentication type, self-signed certificate. It knows we're self-signed. We didn't actually add any devices manually, which is kind of what you'd normally do, and they've been added by the DPS. For added reassurance, in the left menu select Metrics, and then to Connected Devices for the metric and aggregation to max. So yeah, we can go down here to Metrics. Metric, standard metrics, metric, what was that? It wanted us to choose Connected Devices and aggregation to max. Max Connected Devices 2. So I'm guessing that this is 5 minutes. Okay, so probably have to wait a few minutes for that to actually jump up to 3. Which is probably what it should be saying there, 3. I won't make you wait for that. It will eventually jump up to 3 after a little while, but I've just caught it in between those 5-minute windows there. Don't think I can change that window either. So it is what it is. It is what it is for now. So, but we can actually have a look as well. Verify telemetry is being received by changing that metric to telemetry and the aggregation to sum. Go away, fly. Actually, let's do a whole new chart. Telemetry. What is it? Telemetry messages sent. Yeah, that one. And what was it? Sum? Yeah. There we are. Still on 2 at the moment. Just to double check actually, let's just make sure that these are all 3 connected. They are. Interestingly though, what's this saying? Oh right, no, I'm not doing that. Yep, they're all still happy. So it's just the latency in that 5 minutes, which is fine. So then we can see those telemetry messages over time. Yeah, and a 5-minute time period that'll go up as well, but there's no point me sitting there staring at the screen. So now that we've verified that we've all connected, which is fine, we can test the cloud to device communication. So locate the desired properties and add a desired, there we are, temperature to something of, say that, okay, and click save. So this is the device twins for that. So we go to devices again, and then we'll go to device 1. I'm going to make sure that I'm in device 1 here too. And then device twin. And then desired properties here. So that's in the metadata, and I'm going to stick it just here and save that. And if you don't know how device twins work, then this is the methodology where you can set properties that you want to be changed on the device up here in the cloud. And then when the device either polls for that, or it gets sent as a notification, or when it connects and it checks, it can check on what those desired properties are and enact them on the actual device, and then it reports that change back up in the reported properties here. So temperature 60, and we've told it that we actually want a temperature here of, interestingly, it's not got the actual amount there. Oh no, there it is. That's just the last updated in the metadata. So we wanted 50.1234. And there, look, and there's that metadata. And verifying the console that the change was picked up. Oh, there we are, twin property changed, 50.1234, version 2, and then setting the desired temperature to 50.1234. So actually, well, actually, no, it's not going to tell us to do that, but if we refresh this, theoretically, that temperature then will change, but it might be that it's just going to use its random figures, but let's have a look. No, there we are, so the reported has now changed. So it's seen that change, and it saved it and reported that back. So that's all good. What's next? Summary. There we are. So more mouldy cheese. No, I don't know how you people eat it. But yeah, so we've used X509 certificates with DPS, and we've taken leafs off of that root certificate that we self-signed, we created ourselves. And then we provisioned each of those devices using that leaf certificate that we pointed to in that demo code that we had. So the IoT device, it reached out to that URL that is specified here, and it used this ID scope that we've got, our ID scope, with that certificate and this password here, any password at all, for an HSM, and it went through the DPS then and out using a group enrollment to the IoT Hub itself, and created a device in the IoT Hub, and then we were able to send simulated data up. And then after that, we set a desired property in the device twin that was received down to the correct device and then reported back up as a successful change. So that seemed to be good. In short, you've learned how to keep your cheese maturing practices a secret. So that was good. And then we've got some next steps as well, so we can do stuff with Key Vault and a dedicated HSM if you like. And you can learn more here too. So what does DPS stand for? A device provisioning system, device provisioning service, device provisioning security, or device possession service? Device provisioning service. What is the process of verifying X509? Proof of possession, generate verification, add certificate. Proof of possession. All devices connected to the DPS will be configured with this global endpoint. That one. global.azuredevices.provisioning.net, which is what we saw in the code here. Just there. Which allocation policy for your DPS is the default? Evenly weighted, we saw, was the default. So rather than lowest latency, the closest hub to the device, or a static configuration list, we had evenly weighted. Each enrollment group requires one root X509. What single certificate is chained to the root? Oh, I think it's the intermediate certificate. And then you leaf off of that. Hope so. Passwords in our sample code are hard-coded. Certificates are stored locally. What system should be used for production-ready passwords? Password could be held in Azure Key Vault, and the certificate PFX held in a hardware security module. This process example is fine production. No, both password and certificate could be held in an HSM. Don't think so. That Key Vault idea is fine, isn't it? I think. Password certificates are secure and can be stored in the clear. No. Certificate PFX can be held in an Azure Key Vault and the password stored in... okay, that way round actually. I think that one. I don't know. Could be that one. We'll find out in a minute. X509 certificates validate your identity and secure your data through encryption. What's one disadvantage? You need to distribute public keys or fingerprints when creating valid key pairs. Authentication can be revoked. Lower level security than public key encryption. Requires public key infrastructure. Use of these isn't scalable. Requires secret private keys. Can be used for many purposes. With leaf, intermediate and root and several signing mechanisms that are too complex to understand and use. Well, that one. Take a guess at the weakness of self-signed certificates. So low-level hash or cipher technologies might have been used. The lifetime is often 1 year. Self-signed certs aren't trusted by other operating systems. Self-signed certs are often referred to as snake oil certificates. I'd say all of the above sound about logical to me. Which of the following statements is true? A root, intermediate or leaf certificate can be used to validate a device. Root intermediate can be used to sign other no. A root certificate can only be used to sign other certificates. An intermediate or leaf certificate can be used to validate devices. A root or intermediate certificate can only be used to sign other certificates. A leaf certificate can be used to validate multiple devices. Or a root or intermediate certificate can only be used to sign other certificates. Only a leaf certificate can be used to validate a device. I'm not sure. And again, I'm being open and honest, but this isn't my area of expertise, this particular section here, so I'm kind of learning with you at this point. I mean, kind of feels like that one. Yeah. Oh, look. That one then. Oh. That one then, maybe? Look at this. Ah, so that one then. Should have choose my first one. Is it that? I got those ones right. Let's try again. Oh. Yeah, that makes sense. I'm not sure what the answer to this one is. Let's find out what the answer is. That one. That one. Which one haven't I chosen? Requires a public key infrastructure. Oh, and there. Okay. I've got an achievement. Woohoo! That was good. Yeah, all of those things. I'm not going to do that. Okay, that's interesting then. So I'm just going to run through these again then. So what does DPS stand for? We know that, Device Provisioning Service. The process of X509 is proof of possession. All devices will be using that. That's quite right, that same endpoint. Which allocation policy, evenly weighted, we got that right. So each group enrollment requires one root X509 certificate. What single certificate is chained to the root certificate? So I've forgotten that, a verification certificate. So generating a verification code helps ensure proof of possession. Okay, yeah, so we got that code and then we generated the verification certificate. Right, yeah. Passwords, so it was that one. Password held in Azure Key Vault, which makes sense, and the PFX held in the HSM. Okay, that makes sense. There are alternative secure mechanisms, but this is the secure one. It requires a public key. The requirement can increase the initial cost of deployment. Okay. Take a guess at the weakness of the self-signed. certificates. Yeah, so self-signed certificates sometimes referred to as snake oil certificates to express. So what are snake oil certificates then? Oh, okay. So that key is created as part of a post-install script and shouldn't be deleted. All right, I'm not really any the wiser what that is. Which of the following statements is true? A root or intermediate certificate can only be used to sign other certificates. Only a leaf certificate can be used to validate a device. Yeah, which sounded right to me. And I had already unlocked my achievement. So if we were to go back to here, and all of these 900 XP, all of those are finished. So good. Well, again, I'm sorry that I don't know everything there is to know about this, but that's why I was streaming this. I wanted to sort of publicly learn a little bit more about how certification works. And by the looks of it, I've still got to do some more learning, which is fine. I don't mind. So, yeah, thank you very much for tuning into that. And I hope that you got a little from it. Cheers. See you again soon.